You always try to do if you can. You always try to factor. So you're like, okay, you got this, and what's the bottom factor into? Nope. Yep. Correct. And is there any other factoring you can do? Is there any canceling you can do? No. So you're done. There's nothing to do. This right here, said it many times, stop talking. Sum of squares. Do we have any way to factor sum of squares? No. You are done. There's nothing you can do. You can't cancel. There's nothing you can do. You can't cancel. Once again, there's nothing you can do. You can't cancel. First thing you should do on this, what did I suggest you do first? Do what? No, don't do anything. Get rid of what first? That's not wrong, but what would I like you to do first? Not factor, because there's not really anything you can factor here yet. Get rid of the division. Some of you said that and then raise your hands in support. I totally get that. So do this right. Just get rid of that first, because a lot of you, I've seen it already a few times, they just forget it's there and you treat it as multiplication. Is division multiplication? Not directly. It's multiplying by the inner, right? So if you get rid of this, what does it actually become? It becomes, what does it become? Oh, let's move this over here. It gets flipped, right? So if this goes away and becomes multiplication, which we don't say x anymore, right? Because that's just a terrible thing to use in this class for multiplication. What happens? This goes down there, and this goes up here. So just get rid of that first. Again, you can do all those other things. Now, what should you do? Start distributing all those powers, right? What's negative 4 squared? What is that equal to? So just make it 16. So it's 16, a to the 4th, b to the... No, it is not. Negative 4 times negative 4 is 16. Times 9 times a to the what power? 4, b to the 8, all over 2 to the 4th is what? Oh, 16. A to the 4th, b to the 12th times 9, because it's 3 squared. A to the 6th, b squared. And what does this become? A to the what? A to the what? B to the? All over a to the? B to the? B to the 4th, not 8th. I'm writing it wrong. So are there any, if you can cancel something really easy, should you? Yeah, so how about the 16? Let's just get rid of those. What about the a to the 4th? Those go away. Are there any other direct? Oh, look at the 9s go away, right? And the... After you make the easy cancellations, don't try to do it all at once. Don't try to do it all at once. Say it with me. Don't try to do it all at once. Simple mistakes are what down you on these. So just clean it up now, and what's left? B to the 6th, a to the b to the 8th, and what's, oh, b to the 6th, all over b to the 12th, a to the 6th, b squared, b to the 4th. Now, is there a lot we can clean up here? Yeah, it's going to be a to the 4th times what on top? It's b to the 6th, b to the 8th, and b to the 6th, so it's b to the 20th, all over a to the 6th, b to the what? 6 plus 12, 18, right? So what are you left with on top? B to the 2nd, and what are you left with on the bottom? A to the 2nd. There you go. Ah, there you go, 2. It's important that it's negative. A to the negative 2, b to the 2. But what does that mean? What is a to the negative 2? 1 over a squared. That's why it's in the, and then this stays up top because it's positive. So that's why you get that right there. There you go. Exactly. So can you factor the top for me? Nope. Oh. Yeah, say times. So m minus n times m plus n. That's right. And what are you left with down here? N minus m. Is that really close to being able to cancel? What do you know about this right here? What is that equal to? Nope, it's equal to negative 1. So what does this equal? Negative m plus n. Done. Yes, that's right. We talked about this yesterday extensively. We talked about this last week extensively. A minus b is equal to the opposite of b minus a. They're opposites of one another. They're opposites of one another. They're opposites of one another. So therefore, what happens when you have a minus b over b minus a? What does that always equal? That always equals negative 1. So you could write it as negative m plus n or negative m minus negative n. It's the same thing. Yes, Milo? Nope. What did I tell you not 5 minutes ago? What should you do first? Yeah, so it's 8y minus 16 times what? 10 over 3y minus 6. Yes, you could factor first. I want you to get rid of the division first. Oh, I wrote 6. What should it be? 16, 3y. Oh, 16, thank you. Now what can you do? Or what should you do? Yes, you can. What should you do now? There's no cross multiplying because there's no equal signs. What's that word that Milo? Factor. Factor. What can you factor out of this right here? 8. So what do you end up with? 8 times y minus over 1 times 10 over, what can you factor out of the bottom? 3 times what? What cancels? Now you're left with 80 over 3. Done. And or the denominator. So if you see a fraction inside a fraction, that's the general name for that is complex fractions. Complex fractions. So if you were presented with one of these, let's say you were presented with this one right here, how would you go about trying to simplify it? What's one thing that you can think of? What would you do? What's one method you could employ? What's one thing? What would you do first, Connor?
Multiply the top and the bottom so that you would get rid of the fraction.
You could multiply the top and the bottom. You'd have to multiply by the same thing on the top and the bottom, because if you didn't, it wouldn't be 1. So you have 1 plus 1 over x all over 2. What do you want to multiply by? I like this method. Yeah, if you multiply x by both on the top and the bottom, what happens? What's x? Oh, you have these two things, right? So you have equals 1 times x plus 1 over x times x all over. What becomes the denominator? 2x. Is there something in the numerator we can simplify? Yeah, what can we simplify, Liv? Yeah, what does that equal? Nope. Equals 1, yeah. So what do we end up with? X plus 1 all over. Is there anything we can simplify here? No, you are done. I love that method. That is one of the methods. One of the methods is multiply by the least common denominator of the numerator and the denominator, and then simplify. I love that. That's one method. What's another way you could go about doing it? Let's try doing it with this one right here. So on the second one here, you could do it the same exact way. You could multiply the top and the bottom by y if you wanted to, which is a great method. What's another method you could use? What could you do first? Instead of multiplying by y, what could you do first on this one? Well, I'll give you a hint. Ooh, what could you do first? Don't multiply. You could just focus on the... Ready? Ignore that. Can you do something to the 6 minus 3y? To add or subtract fractions, what do you need? You need a common denominator. You need a common denominator. We like the least common denominator, but you don't necessarily have to have it. So, what could we do first? We could focus just on the numerator or just on the denominator. We could simplify one of them. So to add or subtract fractions, you need a common denominator. So if we wanted to simplify this one, how would you simplify 6 minus 3y? What would you do first if you wanted to combine those fractions? Yeah, by what? Nope, you have to multiply by 1. So what does this equal? 6y over y minus 3 over y. What does that equal? Nope. Nope. 6y minus 3 over y. So what does this equal? This equals 4 over y all over what? 6y minus 3 all over. Are you with me so far? Are you with me so far? So what have we done first? We just worked in the denominator. Now, though, dividing by a fraction is the same thing as multiplying by the reciprocal. So what do we multiply by here? What does this equal? Y over what? Correct. Absolutely. Take a look at this. We're going to pause here. Make sure you understand what we can do now. We can't. Yeah, we can just multiply, which means we can cancel what? What cancels? The y's cancel right here. What are you left with, Liv? Nope. 4 over. And you're done. This is another method. This seems a little longer, but in this case it is longer. There are other times when this method is going to be shorter. So how many methods did we just... Best way we can actually practice this is to just go ahead and do them. So for example, this one right here. This one right here. Do you want to combine fractions or just multiply by something? What do you think? Do you want to combine fractions or just multiply by something? Let's multiply by something. What do you want to multiply the top and bottom by, Nick? What's the least common? Nope, you have to multiply the top and the bottom by the same thing. And the same thing better get rid of the denominator. What's the common denominator here? What's the LCD right there? What's the LCD? Yeah, exactly. What's the LCD right here? So what's the LCD of y and y? What's the least common denominator for y and y? Yeah, so you multiply by y over y. If you multiply by y over y, what do you end up with? 2y times, or plus, sorry, plus what?
1 over y.
1 over y times y, which is what, Mar? 1. So you have 2 over y times y. What cancels here? Oh, those cancel. What are you left with? 2y plus 1 over what? Over what?
3y minus 1.
Yeah, and you're done. So when the least common denominators are small, multiply by the denominator. In this case, is this about the best denominator you could possibly have? Say yes, it is. Can you make it a lot worse, or a lot more complicated, or a lot bigger, or have a lot higher power? Absolutely. If the denominators get too much more, what cancels? Thank you for.
Sorry.
No. What? No, that's fine. What cancels? The x minus 3's cancel. Yep. And you're left with 2 times. Oh, x minus 3's cancel, right?
Yeah.
Not the x plus 3 up there. So you have the 2 times x plus 3 all over. Good. You could leave it like that, or you could leave it as 2x plus 6 over 5. That's fine. Either one. Good job.